Hey guys, welcome to our last video for the solutions unit, and this is video 12.5 where we are going to talk about how you can determine, how you can tell if a substance is going to be soluble or going to be insoluble, okay? So there's a couple key questions that I want to walk you through on your scale check and on your trials in the sports drink lab when you're doing the lab. It's going to ask you a bunch of questions, and on your test you'll see a bunch of questions about whether something is soluble or insoluble, and you'll have to know whether something's an electrolyte or a non-electrolyte, and you'll have to determine if something's going to conduct electricity, and lastly you'll have to determine how something is going to how it's going to react with water. Is it going to dissolve into an ion or a molecule, or is it going to not dissolve and form a precipitate? So in this video, we're going to learn how to do all of those things, how to determine all of those things. So we're going to be using the chart that we drew from 12.4, which I redrew down here, okay? And this chart kind of walks us through how to determine whether something is an electrolyte or a non-electrolyte. So I'm going to talk to you how we can use this to help us with polar and non-polar as well. So the first thing on our chart is we have things that are polar over here, and then we have things that are non-polar over here. So before we can really start, you have to ask yourself the question, how do you know if something's polar, and how do you know if something's non-polar? Because that will dictate, which chart you're going to look at. Well, there's a solubility list of rules right here. Let me highlight this. These are your list of rules, and this is on your back of your periodic table as well. These list of rules will help you to tell you whether something is polar or whether it's non-polar. And remember that those two words are synonymous with soluble and insoluble. So if something's soluble, it's also polar. If something's insoluble, it's also non-polar. So they mean the same thing. So the solubility chart tells us if something is polar or non-polar. So let's take a look at that a little bit more closely. So on a solubility chart, I can find a compound on this chart by looking at the anion, okay, the negatively charged part of a compound. That's always the last part of the compound. Okay, anion's always written last or second. So if I gave you a compound like sodium nitrate, NaO3, I would look at the last part of this compound, the anion, okay, and I can find NaO3 right here. This is a list of compounds that are soluble, also known as polar. So anything in this list means it is soluble or it's polar. It will mix with water. Over on this side, though, it tells you exceptions, okay? So if it's in this list, it's non-polar, polar, or insoluble. So for nitrates, something that is made of a nitrate, there's no exceptions. So basically, the Na doesn't matter. As long as NO3 is there, then NaNO3 together is soluble. It will mix in water, okay? Now let's look at another substance. Let's look at silver bromide. So again, we always look at the anion, so look at the last part of silver bromide, and I find bromide right here. So it's in the polar list, right? It's in the soluble list. So you would think bromide is soluble in water, or it's polar. But look at our exceptions. Ag is listed as one of the three exceptions, meaning if Ag is paired with Br, or if Pb is paired with Br, or if Hg is paired with Br, then it's not following the rule, okay? Then it's an exception. So that means since Ag is paired with Br, it is non-polar, or it's insoluble. Let's do a couple more examples. Okay, what if I gave you a substance that was calcium phosphate? Okay, calcium phosphate. Well, again, we always look at the last part of our substance. So let's look at the phosphate part, the anion, okay? Let's find phosphate on this list. And you can look at the soluble list, and you can also look at the insoluble list. Here's the insoluble list, here's the soluble list. So look on all the lists. And where is phosphate? It's right here. That's phosphate. So phosphate is in the insoluble list. So anything pairing with phosphate is insoluble. However, there are exceptions. Here's the exceptions. If NH4 is paired with it, or if any of the alkali metals are paired with it, then it's going to be soluble, right? It's not going to be insoluble. What are the alkali metals, by the way? Alkali metals are anything in group 1. Okay, so that would be like hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Calcium is not an alkali metal. Okay, so it's not following, it's not an exception, which means it's insoluble because it's in that list. Okay, so if there's not an exception, if it's not following an exception, it's insoluble. So let's do another example. What about lithium to chromate? Again, what do we do when we're trying to find if something is soluble or insoluble? We look at the anion. We look at the last half. Cr2O7. Let's try and find that on our list. It's right here. Cr2O7 is in the insoluble list. So you would think this guy is insoluble, right? You think, okay, this compound is insoluble. However, we have to check the exceptions. What does the exception say? If it's paired with NH4, that means it will be soluble. It's not paired with NH4. But it also says if it's paired with an alkali metal, then it's also soluble. Lithium is one of those alkali metals. It's in group 1. So this is the exception. Since it's the exception, it's not insoluble. It's actually soluble, or it's polar. Okay, so you always have to watch out for any of those exceptions. So that's how we determine whether something is soluble or insoluble. Basically, all we do is we check this list and we see if it's in the soluble column, which is at the top, or if it's at the insoluble column at the bottom. So find out which column it's in. And then check your exceptions. Okay. So let's go back and fill in this question. This question asked us, how do you determine if a compound is soluble or insoluble, or polar or nonpolar? We are going to check the solubility chart. Okay, if I can find out on the solubility chart, it will tell me whether or not something's soluble. How do I determine if something's an electrolyte or a non-electrolyte? Well, I'll tell you right now that if something, let's look down here. Where do we find electrolytes and non-electrolytes? Electrolytes and non-electrolytes are under the polar column. Okay, so if something's nonpolar, then we don't consider it as either of those. Okay, so when we're talking about electrolytes and non-electrolytes, we're only talking about polar compounds. So first I have to make sure the compound is polar or soluble. And then how do I know if it's an electrolyte or a non-electrolyte? Well, all electrolytes are ionic compounds. Non-electrolytes are going to be covalent compounds. So just kind of a review, ionic compounds are made of a metal with nonmetals, and covalent compounds are only made of nonmetals. Okay, so if the compound's made of nonmetals, it's a non-electrolyte. If a compound's made of metal and nonmetals, it's an electrolyte. That should make sense because metals conduct electricity, right? So if there's a metal in there anywhere, we know it's going to be an electrolyte. In covalent compounds, there's no metals anywhere. So that makes sense that they are non-electrolytes, okay? And that kind of follows along with anything that's an electrolyte should conduct some electricity. Anything that's a non-electrolyte won't conduct any electricity. Okay, so let's go up there and answer those questions. How do we determine if something's an electrolyte or a non-electrolyte? If it's covalent, it's non-electrolyte. If it's ionic, it's an electrolyte. And then we kind of answered the other one as well. How can you determine if something will conduct electricity? If something is ionic or an electrolyte, then it does conduct electricity because there's a metal. If it's covalent, it's not going to conduct electricity. Or if it's a non-electrolyte, it won't conduct electricity. Now the last one's a little bit trickier. It says, how can we determine if I take a compound and I put it in water, if it's going to dissolve into an ion, if it's going to dissolve into molecules, or if it's going to form a precipitate? Let's go back to our chart down here. Okay, this is ions, this is molecules, and this is precipitate. So how do we know if something's going to form an ion, a molecule, or a precipitate? Well, if something conducts electricity, if something is ionic and it conducts electricity, it's going to break apart into ions that are charged. Okay, charged things conduct electricity. So there'll be a positive and a negative. So if you know something is an electrolyte, if you know it's ionic, that means it will dissolve into ions. If it's a covalent compound that's polar, so if it's a polar ionic compound, it'll form ions. If it's a polar covalent compound, it's going to form molecules, meaning it won't break apart into ions and it won't conduct electricity. If it's nonpolar, it always forms a solid. It will always form a precipitate, meaning dissolve. Polar dissolves, right? We just have to figure out how is it going to dissolve. Is it going to dissolve into an ion or a molecule? And that depends on whether that particular polar compound is ionic or covalent. If it doesn't dissolve, it will always stay a solid. Okay, that kind of makes sense. If it doesn't dissolve, it'll form a precipitate, it'll form a solid. I want you to tell me whether or not it's polar or nonpolar. I also want you to tell me whether it's soluble or insoluble. I want you to tell me if it's polar, I want you to tell me if it's an electrolyte or not. I want you to tell me, again, this is all if it's polar. I want you to tell me if it's going to conduct electricity or not conduct electricity. And lastly, I want you to tell me whether it's going to dissolve into ions, molecules, or form a precipitate. Okay, so I'll do one with you and then you can do the others, or you can try the others on your own. Okay, so KBR, the first thing I need to do is find out if it's polar or nonpolar. And so my notes here tell me to find out if it's polar or nonpolar, it says check the solubility chart. So I got to find KBR on here. And remember, I'm always looking for the second half of the substance. So this is the second half of KBR. And it says it's soluble. It's in the soluble list. And K is not one of the exceptions. So that means KBR is soluble, which is soluble and polar mean the same thing. So number one, it is polar. Number two, it is soluble. Okay. So now I have to ask myself if it's let's see, what's my next question? Is it an electrolyte or is it a non-electrolyte? So remember how I said that if it's ionic, it's going to be an electrolyte, and if it's covalent, it's going to be a non-electrolyte. So KBr, how do I know if it's ionic? Well, if it's a metal and a non-metal, it's ionic. K is the metal, Br is the non-metal. So it's ionic, which means it's an electrolyte. That's an E there for electrolyte. Question 4 says, will it conduct electricity? Well, if it's an electrolyte, it will always conduct electricity. So I'm going to put C for conducting electricity. 5 asks me, is it going to form an ion? Is it going to form a molecule, or is it going to form a precipitate? Well, it'll form an ion if it's an electrolyte. It'll form a molecule if it's a non-electrolyte. It'll form a precipitate if it's insoluble. Okay, so it's an electrolyte, so it's going to form an ion. So I'm going to put an ion here. Now I'm going to do the same for the other substances. Okay, so AlPO4, is it polar or is it nonpolar? Well, I have to find if it's soluble or not. So PO4 is the second half of this substance. So I'm going to look for PO4 in my solubility chart. PO4 is listed right here. Okay, but it's aluminum PO4. Aluminum is not listed on the exceptions because aluminum is not an alkali metal and aluminum is not NH4. So it is insoluble because it's in the insoluble list. So this is insoluble. Then my answer to number 1 is that it's nonpolar, because nonpolar and insoluble mean the same thing. So it's nonpolar, it's insoluble. Question 3, is it an electrolyte or is it a non-electrolyte? Well, if it's insoluble, it's none of those. So I'm going to leave that blank. Question 4 asks if it conducts electricity. And again, if it's insoluble or if it's nonpolar, it doesn't do any of that. Question 5 asks how it's going to dissolve. Will it be an ion? Will it be a molecule? Or will it be a precipitate? Anything that's insoluble will be a precipitate. Okay, so look. All right, so I want you to go ahead and do, I'm actually going to have you just do these compounds I'm highlighting right here. Don't do the other 2 equations. Okay, so just do the ones I highlighted. And that's it for today. Y'all have a great day, and you're done with the videos for the solution unit. Give yourself a little pat on the back.